Welcome to this tutorial on meeting nZEB compliance. nZEB, the European Union's Near Zero building standard, starts coming into effect from 2019 across Europe. We are going to get a lesson from the professor. His lesson will be on using home to meet nZEB versus using a heat pump. We will look at all the details involved and compare all the outcomes. We will be looking at an actual project using Ireland's dwelling energy assessment procedure. We will look at performance and the cost to operate. We will also look at the price of adding home systems to your home to meet nZEB. So what is nZEB? Here is the definition as shown on the European Commission website under their nZEB section. Nearly zero energy buildings means a building that has a very high energy performance. The nearly zero or very low amount of energy required should be covered to a very significant extent by energy from renewable sources, including energy from renewable sources produced on site or nearby. nZEB applies to all residential new build homes. It applies to all apartment buildings. It applies to all commercial buildings. It also applies to all public buildings. And in a groundbreaking move, it will also apply to existing buildings of any age, if you want to modify more than 25 square meters of surface area. This means an extension, a new garage or a small add-on will now require an nZEB retrofit energy upgrade for approval to make these changes. The EU building standard from now until 2050 is near zero energy buildings. We are going to compare a heat pump versus home as your home energy system. But let's first look at what is different about nZEB over previous building regulations. We are all familiar with energy ratings. We have them on our cars, our washing machines, and on our homes. Each year since 2006, governments under the EU Energy Performance of Buildings Directive have been reducing the amount of energy you are allowed, but this has actually been heating energy. Now, with nZEB, the 2050 EU building standard about to become law across Europe, and the addition of a significant renewable energy contribution, is changing the way we build. Under nZEB, the majority of our energy requirements are now hot water and electricity, which is increasing. We are more likely to have more showers in a comfortable home, and increasing electrical use with game and internet devices. The renewable energy contribution of a heat pump comes from the heating energy only. The least amount of energy efficiency from a heat pump comes from hot water. Rather than creating free electricity, a heat pump consumes a considerable amount of electricity, and even requires a larger electricity connection than standard. Now we can look at Home Thermal Electric, the world's most powerful energy technology module, certified by governments in over 160 countries. Home TE was designed to be perfectly suited to nZEB construction methods. Home TE delivers 100% renewable energy, the required amount to heating and large amounts to hot water and electricity, and it is 100% free using daylight as fuel. So let's look at a real housing development about to be built in Ireland. This is the starting DEAP file we were supplied with. You can see it is an A3, has a heat pump and no underfloor heating, but has special low-temperature aluminium fan-assisted radiators in the design. You can see it also has excessive U values on floors, roof and triple glazed windows throughout, which will have added significant cost. But even though this project is an A3, the current regulations about to expire, the heat pump is not able to pass them as it fails the renewable energy contribution. The reason is simple: the heating requirement is now below the capability of the heat pump to produce a renewable contribution. So we will now fix this DEAP failure, so we can demonstrate why the heat pump is no longer the best option for an nZEB home. Now the DEAP file passes as an A3. It now meets the renewable contribution. What we have done is reverse back the extreme U values on roofs, floors, and we have changed the triple glazing to regular double glazing. You can see the U values are now 0.15 for roof and floor, and the minimum U value of 1.4 for a set of ordinary double glazing. This will have a significant reduction in cost. The primary energy value has increased. The EPC has increased. Because we have removed a significant amount of insulation, we have increased the heating requirement of the house, and this has fixed the renewable contribution of the heat pump, as it now has to deliver more heating energy to the home. Of course, this makes no sense. Why would you want to create an extra heating requirement just to get a heat pump across the line? However, it is not important anymore as it only worked for an A3 regulation build, which of course is not nZEB. This developer wants government certified nZEB homes, and he is choosing Home TE as the perfect solution. So we cannot improve this energy rating any further with a heat pump. In fact, we have to unimprove it, to increase the heating bills, to get it to pass the current regulations, which will expire shortly. We will now show you how easily Home meets the new nZEB regulations. We will add 5 home thermal electric modules to the house. This is all we will need to meet A2 nZEB compliance. It is such a simple installation. You can see the roof dimensions required. Now the house passes nZEB with ease. The primary energy and CO2 levels are well below nZEB requirements. The EPC has dropped to 23%, and the renewable contribution is a staggering 2,718 kilowatt-hours per year. However, we won't stop with this. Let us show you how to get a Super A1 nZEB energy rating. We are going to add an additional 5 Home PERC electricity modules as well. These are Home passivated emitter semiconductor panels which greatly outperform older solar PV cells. You can see the roof dimensions required for this installation. We can see this installation easily achieves an A1 Super nZEB. Primary energy is 20 kilowatt-hours per square meter. This achieves a renewable contribution in excess of 4,700 kilowatt-hours, with renewable inputs of heating, hot water and electricity. The EPC is now down to 13%. As can be seen, Home can easily achieve nZEB, and it can easily achieve an A2 or even an A1. Ireland and Europe's best energy rated home is powered by a Home system. Now we will compare all 3 options, but of course only 2 of them achieve the nZEB standard. So we can see that the A3 heat pump does not meet an nZEB standard. The 2 Home options easily achieve nZEB. The total renewable energy contribution is lowest, with the heat pump at 1,079 kilowatt-hours, and a high of 4,761 kilowatt-hours for the A1 rating. The annual energy consumption of Home are as low as €17 a month for heating, hot water and electricity. The heating consumption on its own for the A1 and A2 would be around €7 a month, once a Home system is installed. A logical outcome of having an excellent energy rating is that you have much smaller energy bills. Now we can see all the nZEB parameters in one place. This property is a 107 square meter house. To meet nZEB, you have to meet several parameters which are referenced against a 2006 default property. An EPC of 13%, for example, means that the new house will only use 13% of the energy versus the 2006 reference house. The parameters are an energy rating of A2, primary energy less than 45 kilowatt-hours per square meter per year, a CPC less than 35%, an EPC less than 30%, a CO2 level less than 10 kilograms per square meter. Slightly adjusted U values, and for the first time a new parameter, called the renewable energy ratio, which must be greater than 20%. From the chart you can see the heat pump did not pass any of the energy-related nZEB criteria. Additionally, the Home system options passed all the nZEB criteria with ease. Installing Home into a building is very straightforward. In the example we just looked at, there would be 5 Home thermal electric modules on the roof for an A2 nZEB rating. There would be an additional 5 Home electric modules for a Super A1 nZEB rating. The high temperature heat generated is stored in a special Home thermal store. This heat energy can be used for heating and hot water on demand. A micro boiler is used for backup, and this can be any fuel type including electricity. Standard regular radiators should be used. Underfloor heating can be used, but it is unnecessary and will just make the build costs higher. Underfloor heating also consumes more energy than standard radiators. The roof system also makes electricity which flows into your home. This electricity is used first to power your home before calling any power from the grid. You can also use this power to charge your electric car or battery system, which you can install at any time in the future. To operate the system, you just turn on your heating as you normally would, or you can do it on your phone. 24-hour-a-day hot water is a feature of the system design. This is an example of a home system installation with electric backup boiler in a brand new A1 Super nZEB 250 square meter detached home. Let's look at the cost of a home equipment package for an A2 nZEB. A full Home 5 thermal electric package, which includes all the material parts for installation right down to controllers, inverters, full mounting systems, etc., is €12,562 plus tax. Significant savings can be made on construction costs by using Home. You obviously save on the following items as you no longer need them. No heat pump. No underfloor heating or special fan-assisted aluminum radiators. No second screed. No solar PV. No buffer. No hot water cylinder. No heating controls. No triple glazing required. In fact, you can apply fabric U values to the minimum nZEB requirements. It is important you don't overheat your home in hot weather. This system includes an EV charge point. Now we will look at the cost of a home equipment package for an A1 Super nZEB. This has an additional 5 home electric modules. A full Home 5TE and 5E thermal electric package, which includes all the material parts for installation right down to controllers, inverters, full mounting systems, etc., is €14,866 plus tax. It has all the advantages of the A2 package, but with more savings. Home TE thermal electric technology is the highest rated module technology globally. Home electricity modules are a special passivated emitter rear cell technology designed specifically for daylight, and a flatter annual profile than older type solar PV cells. PERC semiconductor cells produce about 9% more energy than solar PV semiconductor cells. Home thermal electric modules use scattered light for performance, and means they can be used all year round, and excel to high temperatures even in cloudy conditions. Home TE modules are certified to 1 MWh of output performance per square meter per year. Home TE thermal electric technology is being installed across the world. Contact us for any queries on supply, training, design, pricing and specifications. We welcome visitors to come and talk to us. Installer training is available every month. If you currently install heat pumps, solar thermal or solar PV, then installing Home systems will be an easy conversion. Home is especially designed for retrofitting into projects of any age and any type of heating system, both residential or commercial. Thank you for watching our short video.